So we're back for the second part of this bias variance trade-off series. And so in this particular series, what we're going to do is we're going to look and see what does a high bias model mean? What does it look like when we make predictions from a model that exhibits high bias? What are the characteristics here? Okay, so the way we're going to do this is we're going to not just build one model, right? So we're going to actually build 1,000 models. And the reason why it'll kind of make sense in a minute. So what I want to do is we're going to start a for loop here. So I'm going to go for I in range 1,000. Okay, so each time through this loop, what I'm going to do is we're going to build a model, and I'll set it to be my dummy regressor. Okay. Now, what the dummy regressor does is all it does is predict the mean of your data. So I'll show you real quick outside of the for loop. Let's say if I build a dummy, and this is going to be my dummy regressor. And so what I'll do is I'm going to fit it to my training data. So my training data, we'll set this up as two variables. We're going to have X and Y. So X is going to be the data frame with the features, right? So we had that list of features that we set up in the first step. So these are the features that we're training the model on. And if you look at x.head here, you can see that it's just the data frame of those three columns. And so Y in this case is going to be the sales column, right? So if I do sales and I do y.head, so this is a pandas series of the things that we're trying to predict, right? So this is the sales for each market. So we spend this much on TV, radio, newspaper. What can we do to predict our target here? Okay, so what the dummy is going to do is all it does is it just learns what is the mean of your target, and that becomes its prediction for every single row thereafter. Okay, so watch what happens. We're going to fit this dummy. So dummy.fit x, y. Okay, and so if you look at your model's prediction, so I'm going to predict it on the test data frame. So I'm going to call dummy.predict, and I'll do the test data frame features. Okay. Notice here, it predicts 13.98 for that one test row that we pulled off at the very beginning of the first part. So that's its prediction. But that's the funny thing is this is going to be the model's prediction for every single row that it ever sees. So watch what happens when I call dummy.predict on the original data that it was trained on. It's the same prediction each time. And that's because all it learns is just what is the mean of your target. So here, if I just do y.mean, you can see that is basically what it learned. So it's a very simple model, a little too simple, so probably performs rather poorly. But this is a good model to kind of show what does high bias look like. Okay. So now here's the thing. We're not going to just do one model. Okay. What we're going to do is 10,000 of these one models. Now the kicker here is I have to give each model a different data set to train on, okay? So I'm going to do a little bit of code inside of the for loop that's not going to make a whole lot of sense if you're not familiar with what's called bootstrapping. But basically what I'm going to do is I'm going to take my training data and I'm going to call a sample from it, okay? So this is bootstrapping, where you take a sample from a sample, okay? So in this case, the sample is the advertising data set that we got. And so from that, I'm going to sample the same number of rows as before. So I'm setting the fraction here to be 100%. So give me the same number of rows as before, okay? So if you look at when I call shape on this, it's 199 rows, which is the exact same number of rows as the original data frame, okay? Now, in order to bootstrap, you have to sample with replacement. And what that means is, let's say, for example, I have a bag of M&Ms and I'm trying to basically look and see what kind of colors do I have in my bag. So I have my bag of M&Ms, I take an M&M out of the bag and I record its color, and let's say it's blue, okay? So at this point I have one of two options. I can put the M&M back in the bag and then reshuffle and draw again. That is sampling with replacement. I replaced the M&M back into the bag and I'm sampling again. Whereas sampling without replacement is I take the M&M and eat it and then sample another one thereafter. So I'll never see that same blue M&M ever again. So when you sample with replacement, you run the chance of drawing duplicates. And that's exactly what we're going to do here. So I'm going to set replace equal to true, okay? And so notice this time I still have the same number of rows as I did before. However, when you, whoops, must have pulled up the editor there. Whoops, when you sample with replacement, so if I were to look at, if I were to drop all the duplicates from that particular sample and then look at how many rows I have, notice now I only have 124. So the other remaining rows were duplicates, okay? So this is sampling with replacement, and this allows me to have slightly different models that are still all dummy regressors, okay? So I'll show you this in the for loop here as we get down into this part. So we're gonna build the model. It's gonna be a dummy regressor. And so we're gonna set up x sample is going to be x.sample. And so in order to have reproducibility here, I'm going to say, all right, so fraction is 1.0. I want the random state to be the I in the for loop here. So there's where this variable is going to come into handy. So I'm going to set my random state. So that way I get the same random draws each time I do this for loop, okay? And so of course we want to replace true, okay? I need a corresponding y sample. So what we're going to do here is we're going to say y sample is going to be y, and I'm going to index into it, and I'm going to use the index from x sample. So that way the indices line up. I have the corresponding y that matches the x that I pulled from, okay? So now we fit the model, model.fit, x sample, y sample, okay? And then what we're gonna do is we're gonna get a prediction for our test row. So we're gonna say prediction is gonna be model.predict, and it'll be the test data frame features. Okay, so there's going to be our prediction. Now, when you get a prediction on that one row, I kind of did it up here, right? So I got a prediction. I must have deleted it. Oh no, I did it right here. So you're going to get an array of one prediction. So what I need to do is just go square bracket 0, and that way I can just get the one number itself. So coming down here, I'll go square bracket 0, and that gives me the one prediction that I care about. So what I'm going to do is at the beginning here, I'm going to save a list of predictions, and in the for loop, I'm going to append my prediction to this list. So we'll do append pred, okay? All right, so now we're done with the model. We have 1,000 predictions from 1,000 different models. Each one was trained on a different data set, okay? And so with matplotlib, we can actually look and see how different were these predictions from one another. So we can plot a histogram, okay? So I'll do plt hist, and we'll look at the predictions. Okay, and let me get rid of the extra output there. Okay, so you can see these were all my different models. They all had different predictions on that one row. And so you can see there's a little bit of variance here. So we're going from roughly 13 to roughly 15. Now the interesting thing here is I'd like to kind of compare how did all these predictions compare to the actual target itself, the thing that we care about. So what I'll do is using matplotlib, I'm going to draw a vertical line right where that true value was. So I'm going to go plt xv line. And so that'll be the test data frame, and it's going to be the sales, and it's just the one thing that I care about. So it's just that one sample. So it's over here, way over here in blue. Let's make it red, just so it stands out. Okay, this is what high bias looks like. Every single instance of my model was not only wrong in its prediction, but it was consistently wrong, okay? So whenever you build a model that is overly simplistic, it is not going to find the truth. It's not going to essentially get close to the truth of your prediction. Okay, and we can kind of see that here. We built 1,000 models. They were all way off, and they were all under this prediction. Okay, that doesn't mean it's going to be under guessing every single time. You know, sometimes it'll overguess and sometimes it'll under. But the key here is that it's going to consistently be wrong, either under or over. Okay. So I have all these models that were all built on different data sets, and they're all making these predictions, and they're all consistently wrong in that they underpredicted our target for this one particular instance, okay? So that's bias. That's when your model is just way off from the target, you have error due to bias, okay? Now, the other part where you hear that concept of variance, that's basically just calculating the variance of these predictions, okay? So notice the histogram here is rather tight. All of these models were rather consistent in their predictions between each other, okay? And I could do, using NumPy, I could calculate the variance of those predictions, right? So we can see that obviously it doesn't really make sense right now, but we'll see it compared to a decision tree in the next video, and we'll see that it's going to be actually orders of magnitude smaller than the variance that we get from decision trees, okay? So with that in mind, let's cut this video, and then we'll look at the next step, and we'll actually look at a high variance model, and that is the decision tree.